Okay, ladies and gentlemen, today is about attention to detail. If you were to look at these up here, you would notice these four things are very similar, right? We're talking about the sides of triangles or the angles of triangles, and there's these different relations here. And basically, these are four ways to prove that triangles are congruent. Okay, these are all called they are all called congruency conjectures. Okay, all of these I'm just going to write this down. They're called congruency conjectures. And I'm not sure why they use the word conjectures. Conjecture is the same thing as the word theorem, if I can spell theorem. Conjectures and theorems are the exact same thing. So if someone said congruency theorem, they say congruency conjecture, it means the same thing. Okay? What's different is something called a congruency statement, which we'll see a little bit later on. Okay? So conjecture or theorem, we're basically at four of them. Here's one, here's two, here's three, and four. Okay? And these should be very straightforward. They should be very simple, but they mean something different. Okay? Like angle side angle is different than angle angle side. They mean different things. Okay? And really today the picture is going to probably be the most important thing. Okay? So this basically says that if three sides of one triangle are congruent to I'm going to say the corresponding three sides of another triangle, then the triangles are congruent. And this is very abbreviated. If the three sides of one triangle are congruent to three corresponding sides of the other triangle, the two triangles are congruent. Okay? So let me draw the picture, and I think it'll make more sense to you. So if we have a triangle that looks like this, we have a triangle that looks like this. I'm going to label these A, B, C, D, E, and F. Okay? Simply like that. Okay? And if I have one side over here congruent to this side over here, if I have this side down here congruent to this side here, this side over here congruent to this side over here, then all of a sudden I can say that triangle ABC is congruent to triangle DEF. Okay? And that is a congruency statement, what I just wrote over there, the notation. So that's the congruency statement. So basically the idea here is that three sides of this first triangle are congruent to the corresponding sides. They're not all congruent, they're not all the same length, they're three different lengths, but the corresponding sides are congruent. The three sides from the second triangle, and the two triangles are congruent. Proving triangles are congruent is a kind of complicated business. Kind of get into it a little bit. It's not as easy as it looks. There's certain characteristics that have to exist. Okay? So if all three sides of one triangle are congruent to three sides of another triangle, guess what? Triangles are absolutely congruent. Okay? Now look at this. Side, angle, side. This will be two sides and the included angle. And then I'm going to put dot, dot, dot. Okay? And here's what that dot, dot, dot means. I'm going to read this again. Two sides and the included angle. Two sides and the included angle. Dot, dot, dot. Okay. Here's what the dot, dot, dot means. I do not have enough room to write all this, but here's what it is. If two sides and the included angle of one triangle are congruent to the corresponding two sides and the included angle of the other triangle, then the two triangles are congruent. Okay? There's a whole bunch of stuff. There's no way that would all fit in that box unless I wrote like really, really, really small. And then you'd all argue with me because I couldn't read it whatsoever. But it's basically two sides and the included angle. So let me draw one of these triangles. Obviously all these triangles are going to look identical, but here's the idea. You would have two sides, so let's just say this side and this side. Oh, it can be like this. And then the included angle. Okay? The included, that means the inside part of it. So if I was to talk about like my arm, and I talk about here's my forearm, here's like my bicep and my upper arm part of it. And the included angle would be like my elbow. Okay? It's what's in between. Okay? So it's like my elbow. So the included part would be like up here. Okay, so that's the first triangle. Then we have like a second triangle. I'm going to actually turn it sideways so you can see that sometimes this happens. And all of a sudden we have, I don't know, this side, this angle, and then this angle right there. Those two triangles would be congruent. Even though they don't have the same, they don't look exactly the same. One of them's turned sideways, it's kind of flipped around. Basically this side is congruent to this side, this angle is congruent to this angle, this side is congruent to this side. And the idea here is if we were to write these things down, if we were to write about it, this would be a side, an angle, and a side. And what we write down for this is side, angle, side. Okay, this is what we write down. We abbreviate them, side, angle, side. Just like we abbreviate this one, side, side, side. Okay, when you identify the pieces, it's in order, side, angle, side. There's no pieces in between, side, angle, side. Okay? What do you think this one's going to be? It's going to be angle, side, angle. So angle, side, angle. What do you think I would write down for the definition? So two angles and the included side. And I'm going to put a dot, dot, dot. There's a lot of stuff in there, but that's basically the idea. Two angles and the included side. Okay. Draw one picture of this. If I were to draw a triangle, and then draw a triangle like this. Two angles and the included side, so it could be like this angle here, this angle down here, that side. And sometimes what they'll do is they'll draw a second triangle and be like basically like right on top of it here. Doesn't quite look right. Here's one. Okay. Those two triangles then end up being congruent. Okay, not every single, by the way, just in case you're curious, not every single combination of sides and angles will work. There's a very specific amount of things that need to happen. And I can explain that to you in just a second here. Because, for instance, there is no side-side angle. There's no angle side-side, which a lot of people think is funny. But none of those exist. Those don't work. It doesn't work. Not every single combination works. Okay? This one is the angle side. And so those would be two angles. And either, I'm going to say not included. Does that make sense? Not included side. Okay, you need to be the corresponding pieces. So let me try drawing a picture of this one for you guys. So we have one side, this angle, and this angle down here. Okay. So it's the two angles, and then either one of these, but it has to then be the corresponding one. So, like if we had the one that was next to the two, like we do right here, we'd have to have the one that's over by the two inches apart. It has to be the exact same corresponding piece. Okay, does that make sense? Okay. These are the only four that work. There's one more that's called hypotenuse leg, and we'll get into that a little bit later on. Not right now. But basically, these are the only four combinations. We will abbreviate them, and these are all called congruency conjectures. Okay. Now, we've already talked about this before, this concept right here. This should not be anything brand new to you. The figure below, it shows the triangle ABC is congruent to triangle DEF. Name each pair of congruent angles and each pair of congruent sides. Check this out. We don't even need the triangles to do it. We can look at this. Okay, let's talk with the angles. What's the first angle listed in each one of these? Angle A, so we'll say angle A is congruent to angle D. Awesome. Angle B is congruent to what? E. Angle C is congruent to angle what? F. Now, how did I do that? Yeah, well, you could. I'm not even looking at the triangles. All I'm looking at is these guys right here. I could say A and D are the very first letter and the first letter. B and E are the second and second. C and F are the third and third. All you need to do, all you need is this congruency statement. This congruency statement, I'm going to write that down. The congruency statement. All you need is a congruency statement in order to make that assumption. Okay, you want to do the sides for us? No? Oh, you have to do two of them. So let's pick AB. That's the first and second. So what's the first and second? That'd be DE, wouldn't it? Okay, let's do the first and last. So that's like AC. What's AC congruent to? Yeah, DF. So it's the first and last. So we have to list the first and last and second one. Okay, then we just do like the last two. So BC. What is BC related to? EF, last two. Notice a couple things. Over here, you need to include your angle symbol. You need to include your angle symbol. Everyone, what do you need to include? Angle symbol, duh. Okay, over here, when we're listing sides, you have to put your line over it like when we talked about AB. You need that line segment piece. You need it. What do you need? Line segment notation. Part of the notation. Okay? Everyone, you guys try number 2. Basically the same thing. All you need is this. You don't even need the diagram. Who cares about the diagram? Don't draw a diagram. Do it all based on the congruency statement. On your mark, get set, go. When you're finished, you can check yours as mine. All I did is I listed these in order. The first, second, third one, 1, 2, and 3. And I listed these first, second, third one. And I put the congruency symbols in between. So it all worked out. I listed the first and second, the first and second, first and second, first and second. And I listed the third and fourth, third and fourth. And finally I listed first and third, and I was done. Okay? Make sure you have the right symbols in there. I know you guys can handle this. It's a piece of cake. Here we go. Yes, ma'am. What's your question? Let's decide. Yes, that's what I have right here. GI. Okay, now here's the actual part that we're going to talk about, trying to prove these are congruent. Okay, we're doing proofs. This is what these are generally called. They're called proofs. And here's the idea. You need to mark everything on the diagram. If there isn't a diagram, draw a diagram. You need a diagram to do this. You need a diagram. Okay, in the diagram, okay, this is a shortcut. Instead of listing and proving all 6 of those components like we just did, instead of showing all 6 of these things are congruent, all we need to do is have sort of a shortcut and maybe do those combinations of 3 that we just talked about. Side, 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 angle, side, angle, angle, side, and angle, side, angle. Those 4 will work for us. We don't need to do all 6. We only need 3. We need to be a very specific 3. Okay? So this diagram, we're going to mark the diagram. Okay? How do I show that GH is congruent to HI? How do I show that on the diagram? Let's use a tick mark. So 1 tick mark here, 1 tick mark here. That's what this says. That's my tick mark. And the second statement right here says KH is congruent to HJ. Now, I don't know if those are congruent to the other one, so I can't use 1 tick mark, so what am I going to use? 2. So I'm going to write KH. That's going to be congruent to HJ. Okay. Is there any congruency statement that says if I have a side and a side that I can prove the triangle is congruent? Is there anything that just has 2 pieces of information? No, all of them have 3, right? Okay. So I need to find another side, or I need to find the included angle. Is there any way that we could prove these sides are congruent that you guys can think of? No? Okay. What about these 2 angles that are right across from each other? Is there a way to prove these guys are congruent? Yeah, how do you prove those 2 are congruent? Well, they're vertical angles, right? You could say those 2 are congruent because they're vertical angles. Okay? And because of that now, because those triangles are, well, because those angles are congruent, we have a side, we have the angle inside of it, and a side. We have a side, angle, and a side. So which congruency conjecture proves these 2 triangles are congruent? Side, angle, side. So I just write side, angle, side. Does that make sense? Okay. So it gave us 2 pieces of information, and we actually had to determine the 3rd one to figure out that it's side, angle, side. Okay. Notice it also gave us this triangle congruency. You would have to come up with that, otherwise you'll find your own. Okay. Second one. In the diagram, gotta mark the diagram. It says LM is congruent to PO. Looks like that. N is the midpoint of PM. What does that mean? N is the midpoint of PM. What does that mean? That's right. Okay? Because N is the midpoint of this long section, it means those 2 sides are congruent. Okay? And then it says, secondly here, it says N is the midpoint of LO as well. So we switch colors here. Here's LO, side LO, segment LO, and N's the midpoint, so we could say, hey, that side's congruent to that side right there. Okay? So even though it doesn't tell us that these sides are congruent, by the definition of whatever a midpoint is, if we know what a midpoint is, then we can actually figure out this. Now, which triangle congruency statement are we going to be able to use here? Side, 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 because we have a side, and a side for each one of these triangles. This side and this side, this side and this side, and then finally this side and this side. So it's side, side, side. Triangle congruency conjecture. Okay? Let's try another one. These aren't terrible, but the thing is there's so many different combinations that we kind of got to show a lot of examples. In the figure shown below, measure of angle B, that's this angle, is equal to the measure of angle X. That looks like this angle. Okay? VJ, this side, is congruent to JX, that's that side. And UJ, that's right here, is congruent to JW. Okay. I did say W. No. Can side angle side, I'm sorry, can side 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 or side angle side congruency theorems be used to prove these congruent? Okay? Is there such thing as side side angle? No, doesn't work. Angle, angle, side. I disagree. Okay, but here's the question. Is there any way that we can prove all three sides are congruent? No, there's not. Okay, so let's think about this one. Side, angle, side. Let's look at where we're talking about. Here's a side here. Here's a side down here. We'd have to talk about this angle that's in between, right? Okay. Here's a side, here's a side. We'd have to talk about this angle in between. Is there any way that we could prove this angle congruent to this angle? Yes, why? Vertical angle. So yeah, we could actually prove this triangle congruent. Those two are congruent. Those two angles are congruent by the vertical angles theorem. They are vertical angles. So we could prove this is congruent by, no, not that one, by side angle side. Okay, so let's answer the question here. It says, can you use side angle side congruence theorem to prove that these triangles are congruent? The answer is yes. Okay? Explain your reasoning. Okay? Here's what I would say. I'm going to try to write it all down. If we have, I don't even know what it was, if we have two sides, congruent to two sides, then in order to, wow, I don't know about it, to use SAS, we need to have the included angles congruent. Angle BJU is congruent to angle XJW. Why? Because they are vertical angles. Thus, triangle BJU is congruent to triangle XJW. Yes, you do. This is called a paragraph proof. This is actually a very short paragraph proof. But you describe what is given to you up here, that two sides are congruent to two sides. Then you describe what you need. So you describe, I'm going to write this down so you guys can follow this. You describe, first off, what's given. You describe what you need. And then you describe how you determine that stuff. So for instance, that we needed, how do you determine? So like, we needed these two angles. So how do we determine it? We determine those two were congruent by the vertical angles theorem. And then at the very end, you basically say this triangle is congruent to this triangle. Okay? Whatever you're trying to prove, you prove it at the very last line. So basically, whatever information is given to you, whatever information you need, how you're going to determine that stuff that you actually need is actually congruent. And finally, whatever you're trying to prove, you write that at the very end. Geometry 10 years ago, or 15 years ago, or 20 years ago, or 30 years ago was a lot different than geometry is now. You guys are in a class called Algebra Geometry 2. The idea is that we are actually integrating algebra and geometry. People taking geometry right now are also basically integrating algebra and geometry together. There's a ton of algebra in geometry classes nowadays. 15 years ago, 10 years ago, 20 years ago, 30 years ago, there was not. And there was basically geometry was in geometry class. There was very little algebra whatsoever, solving equations, doing anything like that in geometry class. There was tons of this. I wrote paragraph after paragraph after paragraph. I did proofs for probably 3/4 of the year. Not just one semester, but 3/4 of the year. The other times I was basically using something like a 3 and 1 and basically drawing the shapes the other times. Okay? So that's the idea, is that proofs took up a long time than drawing shapes like the other stuff. We did absolutely no algebra in our geometry classes. Number 6. Okay, we're getting close to the end here. I realize that we have about 10 minutes left, but here's where we're at. In the diagram, angle DCA, that's this angle right here, D then C then A, is congruent to angle CAB. Angle DAC, DAC, that's this angle down here, is congruent to angle BCA, this angle up here. Prove that these two triangles are congruent. It does say to mark your diagram. It doesn't need to tell you to mark your diagram. It just should assume that you need to mark your diagram, so please do that. Right. What else is congruent here? Are these two triangles touching each other? Yeah, they are. Do they overlap anywhere? Do they share a side or anything like that? Yeah. This side is the same as itself, right? Both triangles share side CA, right? So technically, if I was to separate these triangles, I'd have a triangle down here that looks like this. I have another triangle that's like up here like this. Okay, I have this angle, this angle, this angle, this angle, and then I have these two sides that are congruent. Do I have enough information now? I sure do. Okay, what information do I have? What conjecture can I use? Okay, you have to look at the diagram here. I have an angle here, I have the side in between, and I have an angle right here. What is that called? Angle, side, angle. You need to look at the diagram to figure out what information you have. Angle, side, angle. Next one. AB is congruent to RE. Done. You're marking your diagram. Angle B is congruent to angle E. Good. BC, that's over here, is congruent to EW. Just like that. Okay. Can I prove these two triangles congruent? Yeah, what do I have? I have a side, and I have the angle that's in between. It needs to be the angle that's in between, like the elbow is in between. If my elbow was somewhere else, like where my fist is at, this wouldn't work, would it? No. Okay? It needs to be the angle in between. So this is SAS. SAS. Don't call it SAS. That's weird. Sine angle side. Somebody want to write the congruency statement for us? I'll do the first one for us. All I'm going to do is I'm going to write this in alphabetical order. The first triangle, write in alphabetical order. This is just a general rule of thumb. Write in alphabetical order. That's triangle ABC. That's really easy. Okay? The second one is not always going to be in alphabetical order. Okay? Don't just always write the second one in alphabetical order. Don't do it. Okay? But what, if we look at this, angle A over here has no markings. And it's on the other side of this line that has just the one tick mark on it. So if I was to look over here, it looks like angle A and angle R are related, right? Let's say A was first, I'd have to say R is first as well. B over here is my angle in between, so that would be along with E. And then W and C seem like they're associated with each other, so doing that. Okay. And my triangle ABC is congruent to triangle REW. Okay. Can we prove these two triangles congruent? Yeah, how? Side, angle, side, it's one side here. The included angle on the other side. like that. Congruency statement. First one, please. ABC. It's congruent to triangle. Make sure you use the right notation. Make sure you draw triangles at the beginning. What do you got? Yeah. Okay. In that case, very simple. It was an alphabetical order. That won't always happen. Is everybody okay with this? Anyone have any questions so far? All right, we're going to keep going. Sam, can I prove these two triangles congruent? Yeah. Here's an angle here. Here's an angle here, and it's a side away from it. But be careful. Go back to the original form. What are they? Go back to the first page. There's no such thing as side angle angle. Okay, there is something called angle angle side though. Okay, you need to say it specifically. Sam, name the triangle for us. Triangle congruency statement would be what? You want to say AEB, so he's not going to follow my rule of thumb, so it's going to be a little difficult. That's all right. I wish he would do it alphabetically because that makes it a lot easier for us to check. That is correct. Okay. Most of you would probably write this first one in alphabetical order, which I really would appreciate, which would be ABE is congruent to triangle, and you would just switch those around. Whoa, that's not good. Oh boy. C, oh boy. C, B, D. Last one. Why don't you guys try this? Try this last one. Make sure that you're able to do this. Yeah. Yeah. One piece of information that you need to find is that is MT is congruent to MT. It's the same side. And because of that, since you have an angle here, you have an angle up here, and you have the included side. So it's angle, side, angle. Hopefully that makes sense to you guys. I know it's not always the clearest the very first day you spend on this. We will work on this not tomorrow because it's all school testing day, but on Thursday. We'll also work on it Friday. If you guys are really getting bad at this, we'll also work on Monday, Tuesday, Wednesday, Thursday, and Friday of next week as well. We need to understand this. This is a tough concept. We need to keep going until people understand it, okay? You guys do have an assignment there. It will be due on Thursday, so we do not have school tomorrow.